Okay, so so your review question numbers 7 through 10 say all solutions. Okay, so question numbers 7 through 10 say all solutions. We didn't get a chance to talk about this yesterday. And this question and the question we did yesterday required you to use the Pythagorean identity. So I'm going to write that out again too. This is the Pythagorean identity right here. And if you want to, you could take a picture of this. And the reason why is because I have rearranged it 2 different ways. And that's really, really, really important here. You should know that if you have sine squared plus cosine squared equals 1, that can also be written as sine squared equals 1 minus cosine squared, and cosine squared equals 1 minus sine squared. How did I get these 2 variations? What did I do? How did I go from this one to this one? What did I have to do with this one? Subtract cosine. And for the second one, I would subtract sine. So all 3 of these are the same theorem, just rearranged. Okay, so that's really, really important to have or to know and to understand, because we're going to work with this a lot after the quiz on Friday when we finish out our unit circle journey. We're going to work with this a lot. Okay, so this is a really, really important theorem that we use coming up. All right, any questions? All right, so we have to do a substitution. So when you look at question B, do you see how this says sine squared? I cannot solve this the way it's written right now because I have 2 different ratios. I have a sine squared and a cosine. You can't take a GCF out of that. This is the same thing as saying x squared plus y equals 1. I can't solve that. I don't have enough information. I need to do a substitution. And the substitution I'm going to make is with sine squared. So what else do we know sine squared to be? We know that sine squared can also be written as what? 1 minus cosine squared. So I'm going to rewrite this as 1 minus cosine squared x. Everything else stays the same. Now this is a quadratic. Whenever it's a quadratic, you have to set it equal to 0. It doesn't matter if you're factoring it or using a quadratic formula, which we're not doing a quadratic formula. Don't worry. Everything is factorable. Okay. So what I need to do is subtract this 1 over. I'm going to subtract the 1 and set it equal to 0. So when I do that, I have 1 minus cosine squared x, and then it's plus the cosine x. And then what happens when I subtract the 1? What do I get? What is when I move the 1 over, it becomes negative 1. All right, so I'm trying to make it all colorful, so we're hopefully staying along. This one is easier than what we did yesterday. All right, what do you think what should you do now? Combine your like terms. Or cancel out your like terms. Yep, cancel out your like terms. So you have 1 and a negative 1. And 1 and a negative 1 is going to change to what? Okay. All right, so this actually is a lot easier. What do you think we're going to do next? And if you want to, we can do it. We can do a substitution at this point. We'll say u equals cosine. So I have negative u squared plus u equals 0. So maybe that helps you. So now I'm going to ask you again, what do you think we're going to do next? How do you solve this? What'd you say, Marcus? We can do that. Let's go ahead and divide by negative 1. If I divide by negative 1, that's just going to change this to a positive u squared minus u. Okay. And take out a u. Yes, take out. And I heard it over here too, but I only heard Lance, so I ignored him. Because I need more than just one person to do well on the test. We're going to take out our GCF, which is a u. So if I take out the u, what do I have left inside of my parentheses? U, and what else? So when you're taking out a u, you're dividing both of these by u. That's what greatest common factor is division. U minus 1. So now we're setting both of our factors equal to 0. So I have u equals 0, and I have u minus 1 equals 0, or u equals 1. So we've actually finished the question-ish. Now we're going to go ahead and, what did we say u was? Which trig ratio does u represent? Cosine. So now we're ready to go to our unit circle. So where on your unit circle is cosine 0? And then where on your unit circle is cosine positive 1? So let's start off with cosine being 0. Let's start with that one. Cosine is 0 at pi over 2 and 3 pi over 2. Now, this is where the directions are important. Remember how in the beginning I said highlight where the instructions? And I think that's what you really have to pay attention to, the instructions on Friday. We will be lenient in our grading now. But if it said an interval 0 to 2 pi, that means I only want the answers on the unit circle. But if it says all solutions, that means I want answers from negative to positive infinity, which simply means that you need to add plus minus 2 pi n to your angles. Whenever it says all real solutions, you need to add that plus or minus 2 pi n, because every angle that you see on the unit circle, I can rotate to the left 360, or I can rotate right 360 and get additional answers. That's what all solutions means. So all you have to do is add the plus 2 pi n. So it's not a complicated thing, but that's the meaning behind that. So when we figured out that our first angle was x equals, what did you say the first one for 0 would be? So it's pi over 2, but I need to add plus minus 2 pi n. So it's 90 degrees plus 360 over and over and over, or minus 360 over and over and over. And then what's the other place where cosine is 0? So we got 3 pi over 2. Add that plus minus 2 pi n. So these are my first two solutions. So I'm just adding that plus minus 2 pi n. So when you look at the answer key on Canvas, I've already posted it. For those numbers 7 through 10, you're going to see that plus minus 2 pi n. And that's why. It's because it says for all solutions. All right, where is cosine equal to positive 1? So 0. Now, technically, we could also say 2 pi. But it's the same place. It's at the same spot on the unit circle. So we'll just say 0. So x equals, and it's 0 plus or minus 2 pi n. So now we have covered it all. We really didn't talk about that plus minus 2 pi n. You know, in the morning, I'm not really fully awake. So I forgot to talk to y'all about that.